So dear participants, we will start with a new topic today and we will discuss on PLC systems. The actual PLC systems, how they actually look, what is their appearance and what are the various features that are available with them. Now you see there are two common types of mechanical design for PLC systems. We can have either a single box or the modular or rack type PLCs. Okay, the single box type PLC are also called brick type PLCs and are commonly used for small applications. Okay, they are a compact package which contains everything. It contains the power supply, the processor, the memory and the input output units. If we are talking of single box type or brick type PLCs, then such type of PLCs can have less number of input and outputs, and their range can be within 6 to 24 for the inputs and 4 to 16 for outputs, and they can have a memory which can store from say 300 to 1000 instructions. This is not very small one, it is also very powerful, but the physical appearance is small and number of inputs and outputs that they can handle, that is small in number. Okay, now you see the internal block diagram of a compact or single box type or brick type PLC. You can see here it is self-contained with a power supply unit. You have a central processing unit that is already inside. You can have inputs and outputs things available at the user end. Now you can see this is Allen Bradley Micrologix PLC, Micrologix 1000. This is one of the good examples of compact PLC where you can see that whatever there is inside you need not to know. As I have already told you, you are having the terminals. Okay, on this side you can find I0, I1, I2, I3. This is the DC common terminal. That for DC common terminal is there for I0, I1, I2 and I3, and this DC common terminal is there for I4, I5, I6, I7, like that up to 9. Okay, here at the output terminals where you can also see all are VDC. You can see here it is written VDC. That means these output terminals are DC output terminals, and this particular thing is common, and this is the output 0 common, output 1 common terminal, output 2, 3 common terminal, output 4, 5, 6, 7 common terminal, output 9, 8, 9, 10 and 11. Like that you have got the power supply things, and you have got an earthing connection. Okay, this is the port through which you are able to program the PLC. You are having certain status indicators like power, run, fault and force things are there, and you have got input and output ports which are given with small annunciators so that you can see when the ports are activated, they are glown. You have all these things. Now you can see there it is already written DC power. That means it requires a DC power. It is relay output and you have got DC inputs. Okay, so since it is relay output, yes, we are in condition to connect outputs accordingly. So we are in condition, I think, yes, since it is relay output we can connect AC actuators as well as DC actuators. Okay, so these are the common terminal. Accordingly you can decide what to do with that. Now you see that here I have given a family of Mitsubishi compact PLC that whose trade name is Melsec, and this product range is FX3U. Now you can see here that it is FX3U 16MR, 3U 32MR, 48MR, 64MR and 80MR. So it does not mean that these compact PLCs, single box type or brick type PLCs should customarily be small in size. They can be large in size, they can have more number of say inputs and outputs, but it is not modular. You cannot expand it through some expansion module. Okay, so therefore we are called it single box type or brick type. Now bricks, one brick, if you need to build a building you need to have another brick. Therefore brick is a self-contained complete unit, therefore it is a brick type. Okay, now you can see here the power supply that has to be provided is 100 to 240 volt AC direct. Now you can see in earlier case DC power supply was required, DC power was required. Now here you can find that you are able to provide AC power supply, that too from 100 to 240 volt, a very wide range they have provided. That means you can easily understand that the PLC is contained with stabilization units for the voltage or the converter units for the voltage, okay, in its internal structure. You can see for this 16MR model, there are 8 input and 8 output. These are digital types of outputs, and the other things, the dimension is given, all the things you can see that this is a family, and this particular table has been taken from Mitsubishi Electric brochure. Now again, you can classify PLCs in 3 types. One is mini PLC, other is micro PLC, and third one is pico or nano PLC. As the name suggests, accordingly the input and output points, they do decrease or increase. For pico, it is the least number of IO points, it is 15. In micro PLCs, you have got 15 to 128 IO points, and in mini PLCs, you can go from 128 to 512 IO points. Okay. Now let us see what is a modular or rack type PLC. The modular PLC type allows expansion of the PLC system through the use of additional modules. You can add here separate modules. Multiple modules can be added or connected to the hardware of the modular PLC. The several components are fitted on chassis or rack or bus with different slots. Therefore, since it is a rack type system, the modular PLCs are also called rack mounted PLC. Now you see, this is the entire rack or chassis in which there is the power supply unit, there is the CPU, that is the central processing unit, you have got this interface module, then you can have DI module, DO module, they are all separate modules, AI module, AU module, you can have some special function module, or you can have the communication processor, because if we have that I should say you want to have a particular Ethernet communication which is already not available with the device, or Ethernet is available, you want to add an RS-232 communication, so all these things can be added over there. You can have separate modules that you have to attach to the rack. So in the rack, mainly the power supply module is already there, CPU is already there, some DIDO is already there, and after that you can add the things. Okay. Now, what is the rack or chassis? Remember that when I talk of rack or chassis, it is actually the central part of the modular or rack mounted PLC. It's a hardware assembly that can plug every communicating modules together in a single frame. जैसे कि आपके घर में रैक रहते हैं, रैक में हर चीज रखते हैं, वैसे ही द PLC रैक और चेसिस, इट इज द हार्डवेयर असेंबली जहां पे आप सारे चीजों को एक साथ लगा के रख सकते हैं, इलेक्ट्रिकली एज वेल एज थ्रू कम्युनिकेशन आप उसमें लगा सकते हो. Remember that rack or chassis, this is the backbone of a modular PLC system. Next comes the power supply module. It provides the required level of regulating power. Okay, so whatever power you apply to this module, it will regulate the supply and regulate the power, and then it will supply it to the connected modules in the rack, because CPU is one of the module to which the power has to be given, and then comes the other modules to which power is also required. Okay, so you see that PLCs work mostly at what levels? 120 volt to 240 volt AC or 5 volt to 24 volt DC, and the backplane output current is 2 ampere to 5 ampere at 5 volt DC. That is the backplane output current, means that much voltage or current that is supplied to all modules. Okay, so this is, you can see that this module is responsible for providing AC or DC powers to operate the PLC through the backplane bus. That means that inside the rack, actually the power bus is connected to all the members of the rack. That means all the modules to which you are connecting the thing. Suppose you have a rack, you have got one power source, and then all the separate modules are connected to the rack. Then the power supply is given through separate wires through this backplane bus to all of the modules from the main power supply module. Next comes the central processing unit. I don't think that there is much requirement to talk about this, because we have already got the idea of what is a central processing unit is. It has got different modes of operation. Right now we have find a new point, that it has got a different modes of operation. In the programming mode, the CPU downloads the logic from the PC or for editing the programs, and in running mode the CPU execute the program for the process. That is, if the CPU is in programming mode, then you are able to download that particular program to the PLC, and in the running mode the CPU executes the program. Here you cannot download any more program in the running mode. So whenever you want to program a PLC, you need to stop it. You need to stop it from the running condition, then you are supposed to bring it to the programming condition, then you are able to program the CPU. Next comes the interface module. The interface module is optional or an additional module. If you need rack to rack communication for multi-tier configuration, then you need this interface module. That is, there is one rack and you need another rack to be connected onto that, or you need some multi-tier connection for large modules, then you need an interface module. जैसे कि आप लोग देखे होंगे कि ये जो केबल टीवी वाले जो होते हैं बीच बीच में एक बूस्टर एम्पलीफायर डालते हैं. You can think of interface module like that, but it is capable of in very large manner. It actually acts as an interface module for the power system, and it acts as an interface module for the entire bus system. So interface module is an important unit when you need very large module to be developed. Then there is the signal module. The signal module exchanges the data information through the input and output modules. Okay, so input signal modules are there which actually accepts data from digital or analog field, and output module sends the data to the digital and analog field output. So there are field inputs to the PLC, field outputs from the PLC. Field input means, this is a new terminology, field input. Field means the process sector. जैसे कि समझो एक मोटर चलेगा, कहीं तो भी एक वर्क जोन है, एक पर्टिकुलर प्रोसेस साइकिल चल रहा है, वहां पे वो मोटर है, कहीं पे एक वाल्व रखा हुआ है, कहीं पे एक सोलेनोइड रखा हुआ है, कहीं पे एक एनंसिएटर रखा हुआ है, व्हाटएवर द थिंग्स, दे आर ऑल क्रिएटिंग आवर फील्ड, और वहां से जो इनपुट आती है दे आर द फील्ड इनपुट्स. So the input signal modules, they actually get the data or the signal from the field inputs, and the output signal module, they actually send the data or the signal to the output modules, field outputs from the PLC. So these digital or analog IO signal can be interfaced through signal module SM. Okay. Next comes the function module. The function modules are special modules and they can be added as optional module. It is available only for modular or rack mounted PLCs, and normally such type of inputs or output module which are they are normally not there in compact PLCs. Okay, for the function module you can either use analog or digital type of modules because these are specialized modules. And such specialized modules include high-speed counter module, PID module, Voing module, thermocouple module. And if you need further operations like PID, CNC, specific position controller interface, then such type of module cards have to be mounted in the PLCs. Now you see that there are new generation PLCs which accommodate such type of modules already built in onto the PLC, even if they are compact in nature. Okay, they can be added with further modules, but with the basic system, the basic, definitely whenever I will show you one figure. You can see this is a 24-point controller. Okay, this is a 24-point controller and the CPU is here. This is the CPU part which actually have control over all this input output. However, these are the expansion modules where you can add the things. Okay. Now you will see this is the CPU part, this is the CPU part, and all these things are expansion modules. These are the specially expansion IO units attached, you can see, and these are the things. Now many times nowadays it is happening that such type of PLC, when they are coming with the basic system, that is the power supply and the basic CPU is there, that CPU itself contains some of the special functions like motion control, that Siemens Simatic S1200, which can be further added with certain separate modules. But this Siemens S71200 itself, they are inbuilt. The CPU unit is inbuilt with motion control input module. One of the output terminals have got this PTO, that is pulse train output, which is not available in many of the versions of the PLCs. Also you may find FATIC PLC. Some of the FATIC PLCs, they are inbuilt with the PID option. Okay, so many compact PLCs right now are coming who are inbuilt with some of the special functions. So accordingly, this is the function module. Then there is the communication processor. The communication processor again is an optional module. These actually provide you additional communication protocols. This is especially required for specific networking application. The communication processor, whatever it is, it actually exchanges the data between PLC, SCADA, HMI and other systems that are available in certain network. Okay, so communication processor takes care of additional communication protocols that has to be added to the PLC. That is required by the PLC for certain operation. I think this is a typo mistake. Already we have detailed about this in our earlier lecture. This is a simple typo mistake. Additional slide has been put from our earlier lecture. Now you see, we will see some examples. This is micro 850 24-point controller. Okay, now you see these micro 850 controllers are suitable for application that require more digital and analog IO or high performance analog IO. So that means you can see that here we have got a good number of total 24 inputs and outputs digital are there, and there is analog input output also. Now these controllers can support up to 4 expansion IO. So if you require additional 4 expansion IOs, that can be connected with micro 850 type controller. Now there is one micro 850 controller. Here you can see that all additional inputs have been added, and here are the expansion units for IO. You can see that you have got expansion IO support, 100 kilohertz speed, this high speed counter available on 24 volt DC module. You have got high speed input interrupt. You have got Modbus TCP support. You have got CIP serial support. That means you can see here that here you can see that here there is Ethernet port, right? There is an USB port for communication with the PC. Apart from that, you have got the TCP support is there. You have got CIP serial support. You have got embedded 1000 Ethernet port, that is RJ45, this one. You have got 6 embedded high speed counter input. You have got 3 embedded pulse train output for basic positioning XYZ axis you can use. You have got Modbus RTU protocol, that is serial port, Ethernet IP support, embedded USB programming and serial port, plug-in slots to customize according to needs. You have got the plug-in slots available here. You can see the plug-in slots. So this is the basic thing that is so much important, that is so much advantageous in case of modular PLCs. You can add up the things according to your options. Okay, I will also share with this video, I will also share one micro 800 controller, that is a new controller series. New means that it is far younger than its older versions like Micrologix. Okay, so that I will share with you one microcontroller poster that I am having in our lab. So that poster will give you a glimpse of what are the various types of controllers that are available under micro 800 series, and also I will try to share with you the complete brochure of this family. So I stop here with the PLC systems. I hope that things are clear to you. Then you come across the point of selection of a PLC. How to select a PLC? So this basic question comes with inherent question about what is the requirement of the process. If the process requires only one input to be handled and accordingly an output is there, then there is no point of using a PLC. You can simply use a transistor. Automation does not mean that you are to purchase a PLC. You can do automation even with a single diode and an LED. That is also possible. Okay, so that means that you need to be smart enough, you need to be flexible enough to know what is the requirement of the process. So if the process requires, as I have told, one input and only one output has to be handled with accordance to that input, you can simply use a transistor. If the input outputs are less in number, you can use a low cost controller. You can use an Arduino Nano, that is also well good to serve the purpose. And if now you are really sure that you need a good number of inputs, outputs, you need long time, robust, industry standard operation, then you need to go for a PLC. Now once you have decided that PLC is definitely required, there is no other option, now comes whether the field points from which I am to take the data or the signal, they are of analog type or digital type. If they are clearly digital, then there is no point of adding an additional cost for purchasing a PLC which is having analog input outputs along with the digital input outputs which is already inbuilt in the basic processor. Now you see, once you are sure that there is no analog opportunity, then you can simply go for a PLC with normal digital inputs and digital outputs. But at this point, you need to ask your customer or the process end user, you need to ask him whether there is any plan, of upgrading the system, or I should say enlarging the system in such a manner that in near future there will be necessity for any analog signal. If the answer is yes, then definitely you should think of purchasing one PLC which is having analog input output module already attached to it, analog input output capacity already attached to it if you are going for a compact PLC, or if you are in a plan of going for a modular PLC, then there should be definitely capability of adding an additional analog input and output module. You need to know if the particular application is about motion control, then you need to have fast pulse train outputs. If you know that if it is a direct thermocouple measuring process, you have to take the data from a thermocouple, you have to just check the condition of a furnace and accordingly decide whether the furnace has to be put on or off. Then you also know that thermocouple is being applied to measure temperature of the furnace, then you can directly use a thermocouple reading unit to be attached to the PLC. Now if it is there your customer end only wants that furnace should be put on or put off in accordance to the signal from the thermocouple, then you can use your normal DIDO to drive a relay, and accordingly through that relay or some big drive unit you can control the furnace. Now if your end user wants no, I don't want just a relay based control, on off control, I want a complete PID control, then your PLC should be able to support a PID based control. So all these things are there according to the necessity of the end user or the process. You need to decide what particular PLC is going to support you to its best extent. Accordingly you should select the PLC. Thank you for now. I will come up with another topic in next lecture.